Hi, this is Mr. Waterman. This is lesson 9.3b, more on hyperbolas. We're going to do some graphing by completing the square, and we're going to learn about discriminants. So starting off, we have an example. Sketch the graph of the hyperbola given by 4x squared minus 9y minus 24x minus 72y minus 72 equals 0. So we're going to need to complete the square to get this into standard form. And then we're going to determine some of the key features of the graph and go ahead and sketch a graph. So first thing is to get this loose number, add 72 to both sides. All right, and then group the x terms. I'm going to go ahead and group n factor the 4 out of the x terms. All right, so we're going to have x squared minus 6x. And then same thing with the y terms. I'm going to factor out a negative 9. And we're going to get a y squared here and a minus 8y. Alright, so now we're ready to complete the square. We're going to take b over 2 squared, add that to both sides. So on this one, that's going to be a 9. And so we've added a 9 here, so we're going to have to add 36 to this side, the 4 times the 9. And then we have a negative 9. This is a minus 8. We're going to cut that in half and then square it. And we're going to end up with 4 squared, so we're going to add 16 to both sides. Well, 16 in the parentheses here, that's a minus 7. Negative 9 times 16 is a minus 144. That's what we've really added there. Okay, so now we've got some simplification to do. If you total this side up, the right side, we get a negative 36. Here we have now completed the square, so we can write these as squares of binomials. This was a 3, so this is a minus 3. Then we have a minus 9. We have a y. Oops, we have the square right here. We have a y, and we have a minus 4 here. Okay, so last thing to do is subtract, divide everything by a negative 36. And we should have this thing in standard form. When you do that, this y term is now going to be positive, so it's going to move over here. Alright, so this is going to be y minus 4 squared over 4. And then this side of the equation is going to be x minus 3 quantity squared over 9 equal to 1. Okay, hopefully that made sense why I ended up swapping the two terms. So y comes first, so this graph is going to have a vertical axis. Right, center, this has the new format. I'll go get that for you so you can look at it. Okay, put the standard form of the equation for a translated hyperbola here, and this is when the transverse axis is vertical, which we already determined because y is in front here. It has the positive sign. So we have y minus k minus h. So h comma k, our center, we still take the term next to x. That's going to be 3. And we take the number next to y, and that's going to be 4. Note that it's defined as minus in the format. These are both minus, so that you actually take the opposite. So it's positive 3 comma 4. And then, so we found our center. And now we just need to find a. So a squared's looking like 4. That's the denominator of the y term. And then we have b squared going to be equal to 9. And with this, we know that it's c squared equals a squared plus b squared. Alright, 4 and 9 have been super popular tonight, and so we're going to get c squared equals 13 on this, or c equals the square root of 13. Not sure if they're going to want that in the graph, but there we go. Okay, so let's take a look at the resultant graph. Made a quick correction up above. I actually had, when I divided the -9 out, I left a negative in here. It should have been positive, so that drove this into a +4 all the way down, and my center's at 3, -4. So here we go. 1, 2, 3, -4 is the center of this. Alright, so there's that. 3, -4. So we start by plotting the center. Alright, and then I would go ahead and plot the asymptotes. So a is 2, b is 3, so I'm going to go up and down 2 units. Alright, and we're going to go over 3. So, up and over 3, up 2. Those are my vertices. Up and down 2 from the center. And then we define the slope as 2/3. So it's y equals 2/3. And that's the slope of those. But it's centered at 3, -4. So we have to do everything relative to that. So we're just going to go up 2 and right and left 3 units. Alright, from the center. And those will define the points on our asymptotes. 1, 2, 3, 1, 2, 3. Down to 1, 2, 3 over here. Right, we're at 3, so these are both going to be on the y-axis. This thing won't draw tiny points. And that's where we're at. So after the asymptotes, then we use the method I was showing you where we're going to get really close to these asymptotes out here and make sure it's symmetrical and goes through the vertex. So one more topic, and that is going to be looking at standard forms of the equations. So from this general equation, like we started with on the last one, if you just look at the coefficients on x squared and y squared, we call those a and c. So we can then tell which of the 4 conic sections we're looking at. So first of all, circles, if these have the same coefficients, a equals c, then you have a circle. Alright, and that should make some sense to you. Okay, parabola, AC equals 0. What that means is one of these terms is missing. So a parabola either has x squared or y squared, but not both. Okay? So one of these having a coefficient of 0 means that's not even there. And so, for example, x squared equals 4py is the equation of a parabola. So there would be no y squared term. Okay, so you can spot parabolas relatively readily. I don't really even use discriminant to see those. And now we have the last 2 shapes that we have to deal with, and they are the ellipse and the hyperbola. So as we know, an ellipse has a plus between the x squared and the y squared terms in the equation. Hyperbola has a minus, so that's reflected here with our discriminant. A and C having the same signs will mean the product of AC is greater than 0. And so that's an ellipse, and then hyperbolas have unlike signs, so product of A times C, those coefficients, is going to be negative, less than 0. So let's look at some examples. So first thing you have to do is go identify A and C. These are both positive, so I get a positive 100 out of these. They're different, so it's not a circle, and it's greater than 0. So this is an ellipse. And then, oops, I think I'm off screen here, so we'll call that ellipse. Darn it. Then next one, we have A is 8, C, negative 18. These have opposite signs. They're not equal, so this is going to be a hyperbola. Right, and then next one, C, there is no y squared. This is an ellipse. No, parabola rather. In other words, C equals 0, so AC is 0. And then x squared plus y squared, these have the same coefficient of 1, so this is a circle. Because A times C, A equals C. Alright, so now all we have to do is get a problem to solve. So here's a couple of them. Classify the graph of these equations below as one of our 4 conic sections. So go ahead and write both of your answers in the form for 49 and 51. Thanks for watching.